Assalamualaikum Sir Hamzi and viewers. My name is Ahmad Zarfan Daniel. My matrix number is 01DDT23F1184 and I will be presenting the first task of the case study, which is to sketch system design and components. So this is our diagram, and as you can see, this diagram will be used to explain how the fiber optic cable system work. First, we have the transmitter block, which consists of coder or inverter. Then this coder or inverter will receive input from analog tools such as telephone and voice recording, such as telephone, voice and image, and then it will convert the analog information into a digital pulse, which then will be sent into a light source transmitter circuit. If the transmitter block receives a digital information instead, it will be directly sent into the light source transmitter circuit, which then would turn on or off the light source at a rapid rate, and this light will be transmitted into the fiber optic cable light pipe, and which would then be sent into the receiver block. The receiver block consists of four components. The first one being a photocell or light detector, which would detect incoming light from the fiber optic cable, and this would then send it into an amplifier, which would further amplify the light it received into a shaper circuit, which would convert the light that has been received into a digital pulse, and the digital pulse, that said digital pulse, will be sent into a decoder to be converted into a analog output, such as audio output, or it will be sent directly into computer if it is a digital output. Next, key components. We have four key components in fiber optic system. The first one being the optical source, a device that converts electrical energy into optical energy, generating light or infrared radiation for use in optical system like fiber optic communications. The second one, optical receiver, in the receiving block. It's a device that converts incoming optical signal into electrical signal. Third, a connector, a device that allows for quick and reliable connection or disconnection of fiber optic cables without splicing, such as an amplifier or a repeater. And fourth, splicing method, the process of joining two or more fiber optic cables to create a continuous optical path. The second task, technical decision making. We need to decide which method would be the most optimum for the company. So our selection for the optical source, we recommend for the company to use injection laser diodes, ILD. The reason for this is because it is highly efficient. ILDs offer much higher coupling efficiency into optical fibers than LEDs, which is ideal for high speed and long distance communication. It is also very reliable. ILDs provide a narrow spectral width, reducing dispersion and maintaining signal integrity over long distance. And fourth and third, it is cost effective for a long-term purpose. While ILDs are more expensive upfront, their superior performance reduces the need for signal booster and minimize maintenance, making them more cost-effective over time. And its bandwidth. ILDs support higher data rates, meeting the client requirements for high-speed internet. Then, selecting the right optical detector for the system. We recommend the company to use avalanche photodiode, APD. The reason for this is because it has high sensitivity. APDs offer internal gain through avalanche multiplication, making them more sensitive to low light signals. So it is very crucial for long distance fiber optic system. And it is also very efficient. It enhances sensitivity, ensures better signal detection, improving the overall system performance. It is also highly reliable. Although APDs are more complex and require a higher bias voltage, they are highly reliable when installed properly in well-maintained systems.
Seterusnya, saya Lokman akan present bahagian saya iaitu task 3 dan task 4. Task 3, Installation and Management. Ini adalah connector type yang akan digunakan. First adalah FC. FC is a connector with a ceramic ferrule and threaded metal coupling. It is designed for use mainly in environments with lots of vibrations. It is typically used with single mode fibers. Second is LC, which is a small form factor SFF connector that uses a retaining tab mechanism similar to an RJ45 connector. Its connector body is square, just like an SC connector, and is typically held together in a duplex configuration. After that is ST, one of the first connector types widely implemented in fiber optic network applications. ST stands for straight tip connector. It has a round plastic or metal body staying in place with a twisting mechanism. It is slowly being replaced with smaller and denser connectors in many installations. Finally is SC, which also uses a round ferrule to hold a single fiber. It uses a push-on and push-pull-off mechanism, which is easier to use compared to the ST's mechanism, the twisting one, especially in tighter spaces. The connector body is square-shaped, and two connectors are held together with a plastic clip, which is known as a duplex connection. Next, task 4, problem solving and innovation. First is the signal loss problem. To solve it, we will have to inspect the connector ends for any damage or contamination, and if so, we clean them using suitable tools such as isopropyl alcohol and clean tissue or cloth. Then we check if the connectors are properly aligned and attached, as a misaligned connector or poly-attached connector can cause the laser light to leak. Next is the part about the lower cost competitor. Well, first we will focus on our own company's quality by using higher quality materials, which will result in less maintenance and a lower chance of failure. Next is we can try offering extended warranties and support. This is to give ourselves an edge by giving our customers the peace of mind that if something were to happen with the fiber in their home or in their enterprise, we will offer warranties and we can support them for no extra cost. That's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Harif Shiraz Belman. Assalamualaikum. And then my message number is 01DDT23F1028. So today I will be explaining about the question of number 6 in our case study. So the question is about the power measurement and loss analysis. So as you can see, the first question is about explain the importance of decibel dB, dBW and dBm in power measurement for fiber optic. So as you know, for the dB, the purpose is a logarithmic unit used to express ratio, so such as gain loss or attenuation. So why is it important? So it is to simplify calculation over large power range, such as fiber spans with cumulative losses. So the losses in connectors, splashes, and fiber attenuation are additive in dB. So for dBm, the purpose is to represent absolute power relative to 1 milliwatt MW. So why is it important? Is to specify transmitter output and receiver sensitivity, such as transmitter positive 10 dBm, and then the receiver is negative 25 dBm. So it enables straightforward power budget calculation. After that, finally, the last one is about the dBW, decibel watt. The purpose is to represent absolute power relative to 1 watt. So why is it important? It's useful for high power components, amplifiers, transistor, and long haul system. And after that, I will be explaining about the calculation. So as you can see here, as you can see on the question, given the input power of the transmitter is 10 dBm and the receiver sensitivity is negative 25 dBm, calculate the power budget for the system. So the first question is about the power budget. So the calculation is over here. The power budget calculation transmitter input was the 10 and then the sensitivity receiver is negative 25 dBm, and then power budget equals to transmitter minus receiver 10 dBm minus in bracket minus 25 dBm equivalent to 35 dBm. So the second question is, there's an insertion loss of 2 dB per connector and 0.1 dB per splice. Determine the total power loss if the system has 4 connectors and 10 splice. So you have to times the 2 dB with the 4 connectors, and then you have to times the 0.1 dB per splice with 10 splices. So as you can see here, dB total power loss calculation, connector loss 4 times 2, because there's 4 connectors, and then there's 2 dB loss per connector, so equivalent to 8 dB, and then splice loss 10 splice times 0.1 dB, because 0.1 dB splice loss per splice, 0.1 dB loss per splice, so means there's 10 splice, so 10 times 0.1, and then total loss equivalent to connector loss plus splice loss equivalent to 8 dB plus 1 dB equivalent to 9. The final answer, the power budget is 35 dB and the total power loss is 9 dB. If the power budget is higher than the total system loss, this transmission is reliable and the system has a 26 dB margin. It will be giving us a robust performance. So that is all from me. Thank you.
Seterusnya saya akan menurunkan untuk soalan nombor 5, reliable and efficient fiber optic installation. First, visual cable fault locator. This tool helps us quickly identify breaks or bends in the fiber that might be causing signal issues. It sends a visible red light through the cable, so if there's a break or sharp bend, we can spot the light blinking out. This makes it easier to pinpoint the problem area on site. Second, fiber optic power meter. We use this to measure the actual power level of the optical signal being transmitted through the fiber. It's essential to check that the power levels are within the expected range and to detect any unexpected losses during transmission. Last is optical loss test set, or LTS. This tool is crucial for checking the total loss across the fiber link. It allows us to measure insertion loss and ensure that the link meets required specifications. We usually use it during both installation and troubleshooting to verify overall link performance. By using all three tools together, we can accurately identify and fix problems in the fiber optic network while ensuring the installation meets quality standards. Okay, last untuk soalan nombor 7, cost control. Bulk buying. Negotiate discounts with fiber suppliers like Corning. Preventive maintenance. Regular checks reduce costly emergency repairs. Next, team management. Daily stand-out 15-minute meeting to address bottlenecks. Cross-training. Teach technician both installation and testing to avoid idle time. Last is standing out. Certification. Highlight TUV certified installers in marketing. Guarantees 99% uptime or 1 month free service. Sekian dari kumpulan kami. Terima kasih.